We've just finished up 2D arrays, so we're actually moving on to our next unit. Now, funny enough, this is a unit that the topic that we're going to talk about today and for about the next, I don't know, couple videos is actually no longer on the AP. This year in 2026, the College Board has decided that this topic, which is called polymorphism, is no longer going to be tested. So the next bunch of videos and what we're going to be doing in class are actually not going to be tested on the AP. But I still think that this topic is extremely important to learn, and we have the time to do it. So we're going to be going over this in class. I actually think this topic is super interesting. Hopefully you do too. It lends itself to some pretty cool projects. So this unit is all about something called polymorphism. And this is a big word, so let me kind of break it down. You know, the root poly means many and morph means to change. So the idea here is that a variable or an object can be actually many different types. Some people walked into APCSA, this class, having coded before, and in general, if you are that person, this is the topic that you actually probably know the least about. So my goal in this video is to kind of rip off the band-aid with polymorphism. What is this thing and what can we do with it? Big picture. So we're not actually going to be really coding in this video. I'm working in the Polymorphism Demo 2026 project, but we're actually just going to be poking around in it. So this code is already written for us. We're going to use this code to inform our understanding of what is polymorphism and what kind of things can we do with it. So before we even look at the code, let me actually give you an example of what polymorphism is. I'm going to use myself as the example. I am Miss Holman, right? I am a person. Person is definitely one of my attributes. I think you would probably all argue that I am a person, even though I'm, I guess for some of you, just a disembodied voice on the screen. So I'm a person. But more specifically than being a person, aren't I also a teacher? And I swim, so I guess I'm also an athlete. And maybe I'm also a friend. And maybe even kind of beneath the generic athlete, I am specifically a swimmer. And I guess sometimes a runner. And you can actually see that I have this almost hierarchy going on where I have person at the top, which then kind of leads down to a couple of different things here of maybe like, I don't know, athlete and teacher, which are all kind of separate. And maybe these actually lead down to more things like I'm specifically a swimmer. And maybe when I'm thinking about teacher, that actually leads down to specifically I am a CS teacher. And you could actually already see this hierarchy going on where I have kind of what we're going to call a superclass on the top of all of these, which is the most generic version of something, and then these specific subclasses that it kind of goes down into. So in this case, an athlete is a more specific version of a person, and a swimmer is a more specific version of an athlete. Maybe a swimmer shares some attributes with the generic athlete, but maybe it has things that it specifically does. Maybe a swimmer swims laps, whereas the generic athlete might not swim laps. All teachers teach, but maybe the way a computer science teacher teaches is slightly different than the way an English teacher might teach. So you're starting to get the idea that I, Miss Holman, am one person, but I can actually be many different types. So again, the big idea behind polymorphism is that a variable can actually be multiple types at the same time. That's where the poly comes in, right? Poly is many. So let's actually look at the code for this project. And I'm going to say this before we kind of jump in. Some of the early examples we're going to look at for polymorphism are going to feel a little babyish, like, and I don't mean babyish as in easy, but I mean babyish as in like, oh, haha, look, an athlete, a rock climber. You know, they're kind of just these silly little examples. But the whole idea is to just get a foundation of what we're trying to learn here. Polymorphism is used all the time in really interesting ways, but maybe today we're not going to look at the really interesting ways. Maybe today we're just going to get a sense of what's going on. So when you open this project, the first thing you might see is that, wow, there's kind of a lot of arrows on the screen. We have seen some of these arrows before, and you might actually notice if you squint at your screen, the arrows are a little different. Actually, these two here in particular are different than these over here, right? These ones over here kind of have like a dashed line. dash line and a little triangle at the end. And there's the other ones which have kind of a solid line and a triangle at the end, kind of like that. We've actually seen one more type of arrow in this class before, which is actually a dashed line that has just not a triangle arrow at the end, but kind of just a little pointy arrowhead at the end. And you might not have known this about Blue Jay. You probably don't because I haven't told you, but all of these arrows actually mean slightly different things. Polymorphism is actually a big reason why we choose to use Blue Jay, because the visuals that Blue Jay gives you in a project where you're using polymorphism are actually really useful. So these two different arrows actually mean different things, specifically the ones with kind of the triangle heads, like the ones I have in this project, and the ones that don't, the ones I might have seen in my past projects. We're going to talk about two very technical computer science terms here. So these first two arrows, whenever you see an arrow with a triangle head, what that means is that's an is-a type relationship. As in, I can look at this project and say a bird is a flyer, or a runner is an athlete, or something like that. This implies a polymorphism relationship, that in some way the types are kind of related here. Meanwhile, this other one is actually something called a has-a relationship. As in, earlier on in this year, we made a class called Hotel Television, and then we made a program called TV Program. And if you remember, there was actually one of these types of arrows from Hotel Television to TV Program. And that's because the TV Program piece of code actually had a Hotel Television in it. And the way that I want you to think about that is a TV program itself is not a hotel television, but it did contain a hotel television. The way that you can think about this is the difference between, let's say, your hotel room might contain a television in it. That would be a has-a relationship. But a television can either be a flat screen television or it can be a regular TV. And a flat screen television is a television. So you can see that's actually the related relationship there. So before we jump into this, let me tell you a bunch of terminology that I'm going to refer to as I go through this. There are three big ways to do polymorphism. And today we're going to talk about two of them. We'll talk about the last one probably a little bit later on. And you're not really going to understand these words right now. That's totally fine. The first way is you can do something called implementing an interface. The second thing is that you can extend a superclass. And the last one is that you can extend an abstract class. So today we'll talk about these first two, and we won't actually talk about the last one here. So to start, let's open up the thing that says flyer here. And you might notice on top of where it says flyer, for the first time you've actually seen there's something else on top of that, and it actually says interface. So flyer is an interface. So let's open it up. And there we go. There's the flyer interface. Looks a little bit silly. Looks really short. You might be wondering, where is all of the code? There's not much in here. Let me tell you what an interface is. An interface is not a class. Normally, we're used to this beginning with public class something, and that's kind of seemingly gone. Now I have interface in place of class, and that's because these are two very different things. An interface is a promise, or sometimes we think of it as a contract. What does that mean? If you want to be a flyer, so let's say I am some class and I decide I want to be a flyer. That means that I have to do everything that the flyer interface tells me to do. In this case, it tells me I need to have one method. That method needs to be called fly. It needs to take no parameters, and the return type needs to be void. One other thing that's clearly missing here is there's no public or private. So when you write an interface, all you're writing is a list of methods that if some external class wants to be a flyer or be your interface, be that type, it needs to write all of the listed methods here. And the idea is that different things might fly differently. So I can have a flyer, maybe a bird is a flyer, right? That's one of our examples here. But a bird would fly differently than how a ski jumper would fly. And a ski jumper would fly differently than how an airplane would fly. So the idea is if I want to be a flyer, I implement the flyer interface and I have to write one method, which is how does my flyer fly? I have to tell that. This interface has one method in it, but I could totally have more. If I want a flyer to be able to do something else, I can just write more methods down here. And again, you have to list out the return type, the name of the method, any parameters in the parentheses, and then you just end it with a semicolon. Little weird. We're not used to doing that, but this is what an interface looks like. So how easy is it to write an interface? Actually pretty easy. Again, it's just a list of methods. You actually don't have to write the code for those methods because who's going to write the code for the method fly is each type of flyer. They're going to have to say how they fly. So again, what is an interface? It's a promise. It's a list of methods that don't have code in them. And when you implement that interface, when you decide I want to be a flyer, guess what you have to do is you need to write a method called fly. You need to say how you fly. So let's look at a class that actually implements the flyer interface. I'm going to open up Bird. Now you'll notice Bird looks mostly like a regular class, but there's two things that are really important here. The first is at the very top, it's not just public class Bird anymore. It says public class Bird implements flyer. What does that mean? That means I need to fulfill the promise. So what method should I expect to see later on? Is the method fly. And here it is. It's void and it takes no parameters. You might be wondering, what if I say implements flyer and I actually break my promise? Like I don't have a method called fly. Well, let's see what happens. So I'm just going to say, let's say I wanted a method called public void fly. And you can see right after I do that, I actually get this really obscure error up here that says something like Bird is not abstract. It does not override abstract method fly in flyer. And essentially what that means is you broke your promise. So again, it will kind of keep you from moving on. If you promised that you were going to have a method called fly by saying that you're going to implement flyer, then gosh darn it, you better have a method called fly. All right, so interfaces. Why do we care? Because this might seem great and all. Great, an interface is a list of methods and I can implement that interface if I want to have that method. But what is the use of this? Before in this class, we've done things like this a lot of times. Couldn't I make an array list, let's say, of birds called birds? And then in this array list, what type does something have to be for me to add it to? I can only add birds, right? So this would be an array list of birds. And once I have an array list of birds, I can make them fly. I can make them all fly. I can make them all chirp. Great. Any method that's in the bird class. We've been limited when we've used array lists in the past or arrays or any really data structure in Java that it is an array list or an array or a 2D array of one type. Now, that's not going to change. I can't just say array list of bird and also string or something like that. But I can do something really interesting now, which is I can make an array list of flyers. I'm just going to call it things. Now, what could be in this array list of flyers? Anything that implements the flyer interface. So can bird be in the array list of flyers? Yeah, it totally can. Could I have a ski jumper in my array list of flyers? Yeah, I totally could. Could I have an airplane? If it implements the flyer interface, then yes, I could. And what can I now do with this array list of flyers? What do they all share in common is they can all fly. So could I loop through everything in my array list and make them all fly? Yeah, I totally could. Even though every single one of these things could be a different type and they all fly differently, I know they all have that exact same method. And I know that because they all made a promise or signed my contract. One last thing before we move on to the second bullet point here. If I wanted to, I could implement actually as many interfaces as I please. So in this case, I just implement one interface. Birds can also walk. So let's say I had a different interface called walker. I just do multiple with a comma, and then any methods that are listed in the Walker interface, I would also have to implement. So I'm just signing multiple contracts or making multiple promises. I just have to fulfill all of them if I implement multiple. All right, let's look at the next one, which is extending a superclass. So I'm going to quit out of Bird, and let's actually open up Children's Book. Now, Children's Book is just a regular class. There's actually no polymorphism really going on here. Here's my constructor, right? A children's book has a title and a number of pages. I can get the title and I can get the number of pages. There's also two more methods. I can get the weight. Sometimes with little kids, you don't want them like holding a super heavy book because they can't really hold on to it, so it's important to know the weight. And many children's books also have a recommended age, so I can get the recommended age of some children's book. And again, this looks like any other class because it is. There's really no polymorphism going on here. But let's actually look at board book, which actually has an arrow pointing up to children's book. What do you notice right off the bat? Well, the very first line is not just public class board book, it's public class board book extends children's book. How would we say this relationship? Board book is a subclass of children's book. So children's book is what we call the superclass. It's the one on top. And board book is its subclass. The good thing about having a superclass and a subclass relationship is that all the code that I need to write in board book is only the ways in which a board book is actually different than a children's book. Now, I just want to make sure you all understand when I say board book, what I mean. You know how sometimes for really young kids, they have those kind of children's picture books where the pages are cardboard. So they literally only have like 8 or 9 pages and they're all kind of that hard cardboard texture. That's what I mean. And again, if you think about it, a board book is a more specific version of a children's book. So because I made this a subclass of children's book, I don't have to re-implement any of the behavior that existed in children's book. I'll say what I said again, which is I only have to say how a board book is different than its superclass, which is children's book. And why is that the case? This is the big thing with superclass and subclass relationships, and I'm going to put it on the screen over here. The subclass inherits from its superclass. Let me show you what I mean by that. If we look just for a second, just to see what we've got going on here, look at the methods that are in board book. I have the method get weight, and I also have the method get recommended age. Great. I'm going to close out of this. And it's been a little while since we've done this, but I'm going to click on board book, and let's actually make a new board book. So I'm going to choose my favorite children's book, which is, you do have to put this in quotations because it's a string, Where the Wild Things Are. And actually, I have no idea how many pages it has, so I'm just going to guess 22. And look, here's the instance shelf. Here's my board book down here. Now, if you click on this like you want to run it, I can actually find the methods of board book. And you can see here are the two methods that were in the board book class, get recommended age and get weight. Let's see what's the recommended age. Great, it's 4. And if I do get weight, it's 6.9 grams, maybe? Pounds? Probably not pounds. That'd be a very heavy book. So I can use, of course, all of the methods that are in the board book class. The ones that are written in the board book class, these are the ways that a board book is actually different than a children's book. That's why I wrote them in the board book class. But what else can I use? If you look here, I actually have this menu that says inherited from children's book. And if you go here, you actually see more methods that I can use on a board book, like get num pages and get title. You might remember, but when we looked in board book, there was actually no get num pages method and no get title method. It was only get recommended age and get weight. I'm going to say something really important here. When you extend something, you inherit all of the methods of your superclass. So I can use the get title method and it gives me back the title, even though get title is not explicitly written in my class. Board book does not have a method called get title. But because children's book is my superclass, I can use all of the methods of a children's book. I inherit all of the methods of my superclass. If I put the word extends in my class, I inherit everything that I'm extending from. That's why the only thing when I write a subclass that I have to write are new things or things that are different between a board book and a children's book. By the way, if we actually look in board book in the class, there was a get weight method and a get recommended age also in children's book, right? And if you look at the way that I'm calculating the weight for a children's book, that's here. And the recommended age for a board book, that's here. And the recommended age for a children's book, that's here. And you can see that I actually re-implemented these inside board book. Because again, the way that I do it for a board book is actually slightly different than how I do it for a children's book. This is something called overwriting. And I'm going to put this on the screen. Overwriting, that's how you spell it. And what is overwriting? That's when we rewrite a method in a subclass. And that method, the more specific one, that's the one that gets used. So in this case, if I have a board book and I do get weight, that's going to use the get weight that's written in board book, not the one that's in children's book. Why do I want to override? The idea behind overriding a method is if I have more specific behavior in my subclass. If the way my subclass does this method is slightly different, then I want to override it. When you override a method, by the way, it has to look exactly the same. So you can see here, this is public double get weight, no parameters. Here, public double get weight, no parameters. Let's say I accidentally spelled weight wrong. Let's say I forgot the I, get wigged. In this case, I didn't actually override a method. I might have meant to override a method, but I kind of messed it up. So now I actually just created an entirely new method called getWegged, which is not all that useful. Usually you want to override a method. How are these two methods different than the original? Well, if you look between board book and children's book, actually, a board book, the pages are actually just slightly heavier than they are in a children's book. And if you look at the get recommended age, we're going to talk about what this super means in a second, but you can kind of infer this is actually the recommended age that a children's book would have, and it's 2 less for a board book. Again, usually board books are for slightly younger children. So again, what's the advantage here? Could I make an array list of children's book called books? And then could I go through and print out all their titles? Yeah. Could I go through and print out the recommended age for all of them? Yeah. Could this array list have both children's books and board books in it? Yeah, it totally could. And if that's the case, which method gets used? Let's say I go through and I print out the recommended age of everything in here. Well, if the thing in the array list that I had put in was a board book, it'll use the more specific one. So it'll use the one inside board book, this one here. If the thing that's in the array list was a children's book, it'll use the one in children's book. So it'll always use the one specific to that object. Okay, we're still hopefully getting the hang of this kind of superclass subclass thing. Let me write this out a little bit more explicitly for how we can use methods when we extend a superclass. So methods with extending superclass. There's actually 3 different things that we can do with methods when I'm kind of creating a subclass. The first thing we can do is just inherit a method. We see this with the method getNumPages. GetNumPages exists in children's book, but not in board book. But we can see over here that I can still use getNumPages because it's inherited from the children's book class. The second is I can override a method. I want to override methods when the way that I'm doing it in my subclass is slightly different than the way that it's happening in my superclass. Which ones were overridden? Which ones did I override in board book? Well, get weight and get recommended age. And why did I do that? Because it was slightly different for a board book. To override a method, all you need to do is retype the exact same method signature and then just put different code in there. Whatever you want the behavior to be for your more specific thing. And the last thing that I can do, which I didn't actually do in this class, is you can actually just write an entirely new method. So I could have some other method here. I don't know, like let's say board books sometimes need to be repaired more often. It's problematic because they're cardboard, so once it gets bent, you kind of need to put it back in place. So I could have something called public void repair. And maybe something happens inside this method. And in that case, how do I repair my board book? Well, that's specific to a board book. And if I had a children's book, I wouldn't actually be able to use that method because it only exists in the subclass. So again, I can write an entirely new method for my specific subclass. Cool. So we're getting a little more in the hang of extending relationships. Let me close out of this. And I'm also going to delete this instance off my screen. And let's look at this class down here called Marathoner. Now, I'm not going to open it. Let's just talk about a little bit of big picture stuff. What is the superclass of Marathoner? It's Runner, right? It's one up the chain. And what's the superclass of Runner? It's actually this one up here called Athlete. Runner is actually an example of a class that has both a superclass and a subclass, right? A runner is an athlete and a marathoner is a runner. I can chain these things together like this. Let's actually make a new marathoner. It's me. I'm going to run a marathon. I'm actually not. Oh my God, God forbid. But let's put my name in here and I'm going to have bib number, oops, I typed a letter in there. There we go. 39313. Great. Here I am, Kayla Holman, the marathoner. And this is what I wanted you to see. Here are the two methods of the marathoner class. I can get my bib number and I can race. But look, here are the ones I inherit from runner. We saw this before. I can inherit methods from my superclass. And here I'm actually inheriting from athlete. So not only do you inherit from your direct superclass, you actually inherit all the way up the chain. By definition, this only comes into play when you have kind of multiple classes up the chain, but this is super important to know. So I can use any methods as a marathoner of runner and of athlete. All right, let's take a look at another one. Let's open up ski jumper. Look, oh my gosh, that first line's kind of crazy. Public class ski jumper extends athlete, so a ski jumper is an athlete, and also implements flyer, which means I've made a promise with flyer. What method should I expect to see because of this? Here it is. Here's the method fly. And the fact that I extend athlete, what does that mean for a ski jumper is I inherit any of the methods of the athlete class. And what methods do I have to write in ski jumper is really any ways that I want a ski jumper to be kind of more specific than an athlete. Like if I scroll down here, look, the way that a ski jumper trains is probably different than how a generic athlete might train. And they also have this method called get jumps. I'm guessing there's probably not a method called get jumps in the athlete class. Now, I've been a little bit skating over this one thing that's been lurking in these extends relationships, which is the idea of super. So what is that? There's actually two ways that you can do super. We've seen it in two different places. So I'm going to quit out of ski jumper because there's kind of more going on here. Let's quit out of this and let's actually open up, let's look at the marathoner class. We can see that we actually use super in the constructor. And if you scroll down, super is also used in the race method. Let me tell you what the behavior is of those. When we call super dot something, so something like super dot race, or really kind of super dot any method, we always do this in a method that we're overriding. And the idea is that it actually calls the method as it exists in the superclass. So if we think about the way that this is written, if a race is greater than or equal to 10, if the length is greater than or equal to 10, I'm going to race the same way that a runner does. Otherwise, haha, kind of a little joke, but for a marathoner, that's way too short, so it's actually just training for them. So when I use super dot method, that calls the version of the method that exists in the superclass. And I only really do this in a method that I'm overriding. So here I'm overriding the race method. And what I want to say is that sometimes the behavior of my race method is the way it was in my superclass, and other times it actually does something slightly different. The other place that we see super is in the constructor. We can see it right here. So when we see super in the constructor, it's always just super open close. There might be something in here, right? in the same way that there might be something in here if this takes any parameters. So this is in the constructor. And the idea here is that when I call super in the constructor, this calls the constructor of my superclass. The idea when I call the constructor of my superclass, well, let's take a look. When I call the constructor of my superclass for marathoner, what constructor is that going to use? It's going to use the constructor for runner. So let's go into runner. And here's the constructor for runner. So this is what's going to get called. Look, it actually sets up two private instance variables that I don't have access to in marathoner. And what else does the constructor for runner do? It actually calls super in its constructor. So which constructor will this call is actually the constructor of the superclass of runner, which is actually athlete. So let's look in athlete. What will this do? This sets up some more private instance variables: first name, last name, sport, and hours trained. I want to be really specific right now, which is that the private instance variables that live inside athlete only live in athlete, which means if I am in the runner class, I can't access any of these four private instance variables. But by actually calling the constructor of my superclass, I'm actually setting those up so that I can use the methods that I'm inheriting later. If you look in athlete, one of the methods is probably get name. I can only get the name of an athlete if I've stored and set up the name. And to do that, I actually have to call the constructor to do that. So even though I can't access the private instance variable name as a runner, you know what I am allowed to do is call the method get name. And that's because I set up those private instance variables with the super call in the constructor. Whenever we are doing an extends relationship, whenever I'm writing a subclass, I will always have that line super as the first line in my constructor. And any parameters that the constructor to my superclass takes, I will need to put in as parameters. Notice that you don't have to do anything in kind of the top level to make something a superclass. Athlete is just kind of a regular looking class. And if you actually look inside the children's book class, this is a regular looking class. All you have to do is make something a subclass, right? When I'm writing runner, I have to refer to athlete, and that's actually how I make this relationship. So this was supposed to be kind of a big picture video, what's going on generally in polymorphism. Hopefully you have an idea of these kind of first two relationships we can do all the way up here. We haven't talked about this third one yet, but we will eventually. And some ideas of what I can do with methods when I am looking at superclass subclass relationships and what is this super thing. It might feel really clunky right now. This video might have been a little bit overwhelming, and my goal in the next few is to actually just make this a lot easier with lots and lots of examples.